Hi, this is Hamza, and I'm going to be going over my submission for the Game Jam, which is the Pay Respect Simulator, and I'm going to be going over some of the things that I've done in there. We'll start with this real-time volumetric cloudscapes. So I got this idea and basically all of the research from here. So the people who created Horizon Zero Dawn published this research on how they did their clouds in their game, which is based on so how they're doing that is, if I show you in this game that I have. So you can see in the back there you have these clouds which are real time and volumetric. They're moving, they're very dynamic, they change shape over time. If I look into the sky here, you can see they sort of change their shape as they move, and this is a lot like how actual clouds would behave. They also have like light hitting their edges, which is also how clouds behave. So how I'm actually doing this is using a position buffer. I'm calculating a ray direction, and using that ray direction I can show you here in the engine. So I'm actually ray tracing two planes, the first one and then the second one, and that gives me basically a volume to work with, and then in that volume I am calculating density samples using a 3D texture which I've generated. It creates a whirly noise 3D texture, and that whirly noise is what I'm gathering density samples through, which give me basically a density based on which direction the ray is facing. And that density can also be used to calculate light density, so wherever I am in the actual volume, I also calculate light samples of how much light is hitting from the actual light source, and that gives me these white effects here. And that's how I'm doing the clouds. The other thing I'm doing is the volumetric light scattering. So, whoops, you can see here the actual light is very volumetric and creates this sort of God rays effect as you look at it, and it does that with all these different obstacles that are in the way. How I'm doing that is I've generated a occlusion buffer. So if I hold E here, you can see this occlusion buffer. It contains black for all of the occluded objects, and then the one light source in the middle there. That light source is what the calculation of the post-processing effect is doing. So in the shader here, if I show you, it's calculating the actual illumination samples from the position of the coordinate on screen to where the actual light position is on screen, which I'm actually calculating on the CPU side and then sending it to the shader, and then it's getting samples in the occlusion buffer to see what is occluding from that position all the way to the light source, and gathering illumination samples. So if I have something occluding it, it will basically nullify that light sample because something is in the way, and that's how I'm doing the volumetric light effect. I also have this sort of lens dust effect, which is basically a mixture of using that buffer to see how much light is actually being scattered, as well as I'm calculating the position on the screen and basically rendering that area only for that texture. And that's how I'm doing the volumetric lighting. The next thing is deferred rendering. So all of this would not be possible without the use of deferred rendering. So everything is deferred. I have a normal buffer, a texture color buffer, as well as specular buffer and position buffer, and I'm using all of that data to calculate all of the lighting on screen, as well as doing a bunch of various post-processing effects like adding a plane in the sky to create density for the clouds and the volumetric light scattering. So next is physically based rendering, and if I show you the ground over here, you can see it shines in different ways, and it's quite detailed in how it reacts to light. The reason for that is I'm using physically based rendering, so I have a normal map as well as a roughness map and color buffer or color map, which is the albedo, and all of those textures are being combined to create these very realistic effects. So you can see it on the tree here as well. It has quite a realistic look to it based on the lighting that's happening. And this actual gun as well, it has a roughness map and normal map as well as the color texture, and that gives off a very realistic effect on the item. So the other thing is dynamic shadows, and they're real time as well, so you can see these shadows being casted from that statue over there, as well as these trees. Although it is quite low resolution, the reason for that is performance. So if I go over here, I can show you it better with this zombie. As it moves, you can see it's casting a shadow onto the ground, and the shadow is dynamic, but it is quite low resolution because of performance. So you can see the shadow, and as you saw, it got a little more dim. The shadows are also being casted by clouds, and that's part of the ray tracing as well. So it's actually gathering density samples, and then based on whatever the density sample is from this position on the ground, it will calculate based on, so the position on the ground, it'll calculate a ray towards the light direction, and then also calculate density samples to check how much of the light is being blocked, which gives me how much shadow is being casted by the clouds. And then there's various post-processing effects. So the first one would be bloom. As you can see, things that are much brighter, they cast this sort of bloom effect, and you can see it got dimmer because of the clouds, but if I get rid of the clouds, it gets quite bright and then starts to bleed in with its color due to the bloom effect. And those the fence is doing the same thing there. And the other thing is, so there's also this depth of field effect. So if I go close to something, you can see it starts to blur, and things that are far away are also blurry. So if I back up here for a second, things way over there are much more blurry than they are over here. So that's also part of the depth of field effect. And I can show you it better a little bit with this this bush here. You can see the leaves begin to blur as I go near them, and as I go far from them, they're normal. And the same is happening to the gun as well. You can see there's a little bit of blur on the back here. That's also due to the depth of field. And these clouds are also cinematically changeable, so you can change the settings based on whatever type of scene you want. You can make them fully occlude everything or make everything dark, and so only the lights in this area will react. If I brighten it up, you can see they cast a lot more light onto the ground. So that's how I'm doing all of that. Thanks for watching.